Hello everyone. In this video, I want to discuss a low-level design of a parking lot management, which is a scalable and modular approach to vehicle parking operations. In real-world example, customers in parking lot face difficulties in finding available parking spots, keep track of their parked vehicles. Manual ticket systems are prone to error and delay affecting the customer satisfaction. An automated solution that offers easy vehicle entry and quick payment options is required to enhance the parking experience. In this approach, we allow vehicles to park and generate tickets and additional services that like car washing to the tickets and the process of exit requests and calculate the charges as per the hours they are stayed in the parking and accept the payments cash or online transactions. In this approach, we have created 5 files that are parking lot, parking spot, vehicle, and parking ticket and service layer. In the low level design, we have included object oriented principles in this low level design approach for the parking lot. We have included that encapsulation, abstraction, inheritance, and polymorphism. This is the overview of our low level design for the parking slot. Now we will see the implementation of the code. Let's start with the main method. The main method serves as the entry point for the parking lot systems. It provides a user-friendly menu-driven interface to interact with the system. The method performs the following key functions: display the menu options, handling the parking, and add the car services and exit from the parking lot. Now as we see that we have imported all the classes which we have created in the files as the import by using the import method, and then we have initialized the parking spots as in the main method. Here we can see that inside the while loop we have written the how the output display of the parking slot. We have used the switch case method for the cases. The case 1 represents the parking of the vehicle and case 2 represents the add the car wash, and the case 3 represents the exit from the car parking slot. And it is all about the main method which we have created for the parking slot in the low level design. Now we will see the implementation of all classes one by one. First, let us we see the parking spot class, which is an abstract class. It represents the parking spot in a parking lot, which contains the attribute ID, is free, and floor and amount. And the key methods we have included in this: cost, is free, set free, and we have used get ID and set ID for the retrieve of the ID from the class. And we have created an abstract class that is cost in the last. And let's go to the second method, payment services. In this parking slot we have created a payment service method for the payment for according to the hours stay in the parking. And here we have created a public void accept cash method for the acceptance of the cash, and for other methods debit card and online payments we have created another method for the called credit card for the payment. And later we have created the parking slot class, which is represent the parking lot and manage parking spots entrance and exits. It contains the attributes entrance, exit, and the display board and free parking spot, occupied parking spots. And we have method calls get instance and get free parking spots. We can observe that the variables are declared in private and class also declared as private, and we have created the initialize the parking spots. And later we have used get name get set name for the retrieve of the data from the class and set the values for that variables. And later we have created the parking service IAMPL class for handling the parking related operations such as vehicle entry, exit, and parking tickets management. The key attributes present in this parking strategy ticket. And we have added the key methods entry, exit, add observe, notify all observes, and the add wash methods. See the output for the above implementation. Here we can see we have added three values: park a vehicle, add a car wash, and exit from the parking. Now let us enter for the parking. It will allocate parking ID and the spot. Now let us try another option, that is add a car wash. Now we have to enter our car ID and type of the vehicle. It shows that successfully added to the car wash for the car ID. And now we'll try for the third option, leave a car. Suppose we have entered a wrong ID too. It will show that is invalid. It says that there is no car in that spot. And here is the final output of our code implementation for the low level design of the parking lot. Thank you.
So hello everyone. So I am the one of the member of this project. So let's discuss some more classes detailedly. So in that we will discuss firstly vehicle. So the vehicle.java. So in this we in the first line we defined a package with the name of com.demo.dto.vehicle. So why this? Because it helps the structure the code base logically grouping related classes, and we are imported some packages. So and later we take an abstract class. So why we take an abstract class means, so an abstract class cannot be instantiated and serves as a base class for other specific vehicles types, examples like car, bike. This enforces a consistent structure so across different vehicle types. And later that we define some instance variables with private so in that first we see an atomic integer. So why we take an atomic integer means it generates a unique id for each vehicle object. So and next we defined an id and a parking spot enum. So the id the purpose of the id is it holds a unique identifier for each vehicle. And the parking spot so it specifies the type of parking spot required. Example, for if you take in car, it takes what type of spot it requires, it for like small or large area or compact area. And then next we see a constructor. So the constructor consisting of parameters parking spot so it accepts the type of parking spot the vehicle required. And that we use in getters and setters. So the purpose of the get id is to retrieve the unique id of the vehicle. So why? Because we provide an access to the id for external classes or methods. Next, set id. So the main purpose of this set id is to allow the id to be updated. So why mean while unusual for ids to change, this might be used during testing or exceptional scenarios. And now we see the another class. Sorry, we have also in some more classes parking spot so this method is used to this method is used to retrieve the parking spot type required by the vehicle. And it is used to check or validate parking assignment. And another class we also have another class in this class. Another method that is set parking spot so it is used to update the parking spot type for the vehicles. So it allows the flexibility in case the parking spot type changes. And next we see the another class, parking ticket.java. So if we see the parking ticket.java, firstly we have an class declaration. Some packages are imported and some there is a declaration constructor. So its purpose is to represent a parking ticket in the system. So why means it tracks the information about the vehicle, parking spot and timing of parking. And later we have an atomic integer. It is also similar whatever we have seen in the vehicle.java. So this it ensures that no two tickets have the same ID even in the concurrent environment. So if my purpose is a thread safe counter for generating unique ticket IDs. And later we define an instance variables, ID, vehicle, parking spot, and timestamps. So the ID is similar, it holds the unique identifier for the parking ticket, and vehicle, it stores the vehicle object associated with the ticket. That means if the associated with the ticket means car, if it is a car or bike, and so on. And next we have in parking spot, what type of parking spot is allocated to the vehicle. And finally is the timestamp. So it records the time when the ticket was issued. So y means it is useful for calculating the parking duration and billing. And next one is the constructor. So the constructor has some parameters. These parameters are the vehicle and parking spot. And y means it initializes the tickets with the required vehicle, parking spot, and timestamp while ensuring a unique ID. And similarly, getters and setters, because we declare here instance variables are private. So to access this, we have to use we have to use methods like getters and setters. And next we see another class, parking event.java. So parking event.java is so why we use this so in that we also why we use this in parking event means we have some methods in that ongoing we can understand. So first one we have an constructor. So parking event, so it represents an event in the parking system, such as a vehicle entering or existing at a parking spot. Parking is when the vehicle is entered or not. This, so for this we use this class. So it provides a way to encapsulate details of a specific parking event. And in this we also have an instance variables, that means event type. So it stores the type of parking event, such as the vehicle is entered or exited. So y means it differentiates between the various actions that can occur in the parking lot system. And another thing is parking spot enum. So it represents the type of parking spot. Like it is a small, medium, large, etc. It specifies which type of parking spot is involved in the event. And the next one is an constructor we have. And the remaining we have a method set event time. We have a method setters and getters. So it is also same. Here we declare the instance variables are private. To access these things we define, we use the methods. So for the methods we call them getters, and the methods we call method getters and setters. So we call these methods and setters. And next one is the admin. And we see an admin. So this admin.java is helps to, so its purpose is to represent an admin account in the parking system. So in that we have we used in a concept of OOPS called inheritance. It extends the admin class extends the account class, so it inheriting its properties and methods. So and it has some fields, parking lot, so it refers to the singleton instance of parking lot. Ensure all admins interact with the same parking lot instance. And next class is an invalid ticket exception. So the invalid ticket exception purpose is to custom exceptions to handle the scenarios involving invalid parking tickets. So it is also involves a concept inheritance. It extends the built-in exception class. Whenever there is an exception, it gives the exception to us. That means it gives a message. Whenever we get an error, it gives some message. And the next one is a display service interface. So the purpose of this display service interface is to define a contract for updating the display system in the parking lot. And here we declare there is a method declaration. So as we see here, void update parking spot enum int I. So the abstract method to be implemented by any class using this interface. And so this is how the classes work together. If we see how the classes work together, so the when we come to the vehicle class, it represents cars or other vehicles using the parking lot. And when we come to the parking ticket, tracks vehicles entering the lot, assigning them to parking spots. And next one is parking event, so it logs events such as entry and exit for audit or display purposes. And admin class manages the parking IoT via the singleton parking lot instance. And next one is invalid exceptions. Invalid ticket exception handles errors related to the invalid tickets. And display service.java so ensures updates to be parking IoT display for users or admin. So this is the part I have explained. So the remaining will be completed or continued by my another team members. Thank you.
Hello everyone, my name is Purna. I am from AML. I am the third person in my team. Uh, Today I come to here to present my low-level design using Java parking lot services. In this, in nowadays, many malls like Inorbit Mall and Lulu malls are having this automatic implementations of parking lots. In that, we included a car wash system, so they are also giving a ticket generations and that type of services. So today I can present that one. The key feature today my responsibility to service is the displaying the parking spot services responsibilities for creating what the major role that playing parking spot services. The major role of the parking spot service the service is to responsible for creating managing parking spots within a parking lot. Functionality initializes the parking spots based on the managing parking spots within the parking strategies, maintaining an inventory or of available and occupying space spots. If there is any spots are available, means these parking spot services are getting notifications to the observer, which can we see in a display boards. The second one is the parking spots implementation. The parking spots implementation can implement so what the methods are present in a parking spot service. See here we can see a parking spot implemented in .java. Manages a vehicle parking operation, ensuring the smooth entry and exit processes. Functionalities what we are here in parking spot strategies is a find parking spot. Parking spot enum is an variable that can spot as a parking spot. Finding available spot based on the vehicle type, car, bike, truck, etc. Generate parking truck tickets with the details like a parking spot ID, vehicle number, and time of entry. While handling parking fee calculations upon the exist. If any car or any truck based on that they have specified some amount of money, right? So the by using that it can identifies what the type of vehicle that can enter in a parking spot implementation. That can after that everything will be demonstrated on display the services. Keep this is also three major main major things: parking spot services and parking spots implement and display board. These three are very important to maintain the parking spot management automatically. These two are implemented inside, and display board is what the users can see or what the observer can see in a system. Parking spot display board can see so um, what the parking spot get free or free, keeps user informed about parking spot availability in a real time. If there is spot is there present or not, and what the space are what space is empty and what space is available to get a new car to that allocated spot, it can be seen by the user observer in a display service only. The functionality is to update the display boards dynamically to show the count of available parking spots by type, notifying user of the spots availability when entering the lot. if there is any gap means the observer can directly easily easily by giving commands it can generate where the spot is where the vehicle need to spot or allocate a free pace to that. If there is a car it can allocate if it checks whether a car type or car sized spot is present or not. If a truck it can generates allocates the if the free spot is present or not. If there is a present means a display it displays the where the spot is empty, and it displays where the spot is not available, not available. Now in vehicle entrance and entrance means when an when an user enters the parking lot, the system the system identifies an appropriate parking spot based on the vehicle type. A parking ticket is generated with vehicle details like something like a license plate, a number, type, what type of color, and what type of brand that was presenting. By using that details, it can generate whether the ticket price. It decides the ticket price. A parking spot details like it can generate ID, location, where we put, and every spot has unique ID to where we put. It can easily identify by the ID numbers and location as well. Time of entry by getting time of entry also the charges will be beyond extents. If you put in a spot more than 1 hour means one type of rate, and if you 2 hours means one type of rate, and 3 hours means one type of rate. So we need to adjust with that time and time also.